Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn the six trigonometric ratios. Let's start. Let's learn first what is a right triangle. It is a triangle with one right angle or with one interior angle of 90 degrees. For example, this illustration here shows a right triangle since we have one of its interior angle which measures 90 degrees. If you can see this symbol, it means that this angle measures 90 degrees. And of course, the other two angles are the acute angles of this right triangle. And these two acute angles can have this Greek letter theta. If our Greek letter theta is in here, it means that the focus or the viewpoint is in this angle. And if the angle theta or the Greek letter theta is in here, it means that the focus is in this angle. Let's define what is trigonometry. It is a branch of mathematics that deals with the relationships of the lengths and the angles of triangles. Trigonometry comes from the Greek word trigonon, which means triangle, and metron, which means to measure. These are the parts of a right triangle. First, we have the hypotenuse. It is the longest side of the triangle. It is always the opposite of the right angle. So as you can see in the figure, it is opposite to the right angle, this hypotenuse. And take note, this is always the longest side of a right triangle. Then we have the adjacent side. It is side next to theta, but not the hypotenuse. Since our focus or the angle theta is in here, our adjacent side must be this one. Next is the opposite side. It is the opposite side to angle theta. Since our angle theta is here, then this side here must be the opposite. If our angle theta is in here, or the focus or the viewpoint is in here, therefore this side here must be the opposite, and this will be the adjacent side. So we have to look at who is the focus by determining where is the angle theta. These are the six trigonometric ratios. We have three major trigonometric ratios. First, the sine ratio. Second, the cosine ratio. And the third, tangent ratio. First is the sine ratio. It is also called the sine function, usually recalled as the SOH acronym, or the SO for the SOHCA tuwa, which stands for sine, opposite, and the hypotenuse. This implies that in a sine function or sine ratio, we are only taking into account the opposite side and the hypotenuse. For example, using the given triangle, the formula for sine function is written as sine theta is equal to opposite over hypotenuse. Just use the value for the opposite and the hypotenuse. No need to use the adjacent side. Next, we have the second trigonometric ratio. We have the cosine ratio. It is also called the cosine function, usually recalled as the CAH acronym, or the CA for the SOHCA-TUA, which stands for cosine, adjacent, and the hypotenuse. This implies that the cosine ratio deals only with the adjacent side and the hypotenuse. For example, using the given triangle, the formula for the cosine function is written as cosine theta is equal to adjacent over the hypotenuse. So just use the adjacent and the hypotenuse. Next is the tangent ratio. This is the third trigonometric ratio. It is also called the tangent function, usually recalled as the TOA acronym, or the TUA for the SOHCAHTUA, which stands for tangent, opposite, and the adjacent. It is also implies that the tangent ratio uses only the opposite and the adjacent sides. For example, using the given triangle, the formula for tangent function is written as tangent theta is equal to opposite over adjacent. Just use the opposite and the adjacent sides. Next, we have the other three trigonometric functions. These are the cotangent ratio, secant ratio, and the cosecant ratio. Take note that cotangent ratio, it is just the reciprocal of the tangent ratio. Our tangent is opposite over adjacent. Therefore, the cotangent must be its opposite, the adjacent over hypotenuse. Just get the reciprocal. Then the secant ratio, this is just the reciprocal of the cosine ratio. Our cosine is equal to adjacent over the hypotenuse. Therefore, our secant must be hypotenuse over adjacent. Then lastly, we have the sixth trigonometric function ratio, the cosecant ratio. It is just the reciprocal of the sine ratio. Our sine is opposite over hypotenuse. Therefore, our cosecant ratio must be hypotenuse over opposite. Those are the six trigonometric functions and its formula. Now we have the special triangles. The 45 degrees, 45 degrees, and 90 degrees. It is an isosceles right triangle whose two sides are equal. The two sides are equal because this special triangle is coming from a square that is being divided by its diagonal, and it forms two equal triangles. And now we have 45, 45, 90 degrees. And now if we can see this triangle, we can just easily get the six trigonometric functions. We have the sine 45, that is just square root of 2 over 2. No need to calculate since this is special. This is true to all. For the 45, 45, 90, just use this six trigonometric functions. Next, we have the 30, 60, 90. If you can have this special triangle, no need to calculate. Just use this function or values. For sine 30 degrees, that's 1/2. Cosine 30 degrees is square root of 3 over 2. Tangent 30 degrees is square root of 3 over 3. Then just get its reciprocal to get the other three trigonometric functions. Let's try some examples on how to solve for the six trigonometric ratios. First, find the six trigonometric ratios of angle A using the right triangle shown. We have angle A, meaning this is our focus here or the viewpoint. It means that 5 is our opposite and 13 is the hypotenuse and 12 is the adjacent side. Okay, here's the solution. For sine, cosine, and tangent, these are the three major trigonometric functions. We will first find the sine, cosine, and tangent because the cosecant, the secant, and the cotangent, they are just the reciprocal of these three major trigonometric functions. Okay. To get the remaining three, we get the reciprocal of the first three. So we have, these are the three major trigonometric ratios, sine, cosine, and tangent using the formula opposite over hypotenuse for sine. Take note that this is our viewpoint here or the focus. meaning that this side here must be the opposite. So we have 5 over, the hypotenuse is 13, so 5 over 13. And then for cosine A, that is adjacent over hypotenuse. Our adjacent is 12, then the hypotenuse is 13. So we have 12 over 13. For the tangent A, the opposite side is 5, then the adjacent side is 12. So you have 5 over 12. Now, after finding these three major trigonometric ratios, we can now find the other three. For the cosecant, take note that is just the reciprocal of the sine. So just get the reciprocal of 5 over 13. That is why we have 13 over 5. And for the second, that is just the reciprocal of the cosine. So just take the reciprocal of 12 over 13. Now we have 13 over 12. Now, for the cotangent, just take the reciprocal of the tangent, which is 5 over 12. Now, we have 12 over 5. So, that's how simple to find the 6 trigonometric ratios. Second example, in the following right triangle, cosine P is equal to 18 over 17. Find the other 5 trigonometric ratios. So we have here our angle is P, means that's the focus. Then this side here is the opposite side, but we don't have yet the value for the opposite side. We only have the value for the adjacent side and the hypotenuse. So first, we are going to find the opposite side because we cannot find the other 5 trigonometric ratios if we don't know what's the measurement of this opposite side. So by using the Pythagorean theorem, we can find the missing leg or the opposite side. Okay, this is the formula for finding the Pythagorean theorem, or this is the formula of the Pythagorean theorem. A squared plus b squared is equal to c squared. So since we are looking for one of the legs, we will be using this formula. B squared is equal to c squared minus a squared. Our c is the hypotenuse or the longest side, that is 17. So we have now 17 squared minus the one of the legs or the shortest leg. We have 8. That's why we have 8 squared here. Then 17 squared is 289. That's 17 times 17. And for 8 squared or 8 times 8 is 64. 289 minus 64 is 225. Then to get the value of b, just take the square root of both sides. So we have square root of 225 is 15. Therefore, our opposite side is equal to 15. Now we can find the other 5 trigonometric ratio. So find the other 5 trigonometric ratios of angle A. Now that we all have the sides of the triangle, we can easily get the other 5 trigonometric ratios. So for sine P, using the formula opposite over hypotenuse, that's 15 for the opposite. Then the hypotenuse is 17. For its opposite, the second P, that's hypotenuse. Oh no, the second P is the opposite of the cosine. The cosine is already given, which is 8 over 17. Here, cosine P, that is 8 over 17. So its opposite is 17 over 8. Next is the tangent P. That's opposite over adjacent, which is our opposite is 15, then adjacent side is 8, so we have 15 over 8. And then for cotangent P, that's the reciprocal of the tangent, so we have 8 over 15. And then for the cosecant P, that is just the reciprocal of the sine, so we have 17 over 15.